Also, if we look at question 6, here we are told given the following observations, experiment 1, experiment 2, and then experiment 3. So we've been given the values in respect to reactant A and B, and then also the initial rates. Now, the statement continues to say the reaction between A and B is first order, okay, in terms of A, and 0 in terms of B. So if we're going to come up with a lateral expression, our rate is going to be expressed as K, and then in respect to A we are told it's first order, so the power 1, and then to B the power 0. So this basically just is going to remain as R is equal to K, and then B does not have an effect on the rate since it is raised to the power 0, which implies every time it doesn't matter the value there, it will always be a 1. So this is our lateral. Now, for us to find the values of x and y, how do we go about it? So it means we're trying to find the value of R and A respectively. Okay? Now, we have to look at experiment 1 because in experiment 1, all the values are known. So we can therefore find the value of K. So let's substitute. So for experiment 1, the initial rate was 2 times 10 to the power negative 2. The value of K we don't know. Value of A, which is the concentration, was 0.1. So divide by 0.1 on both sides. 0.1, 0.1. So here you notice that the value of K is going to be 0.2. Okay. Now, if you look at the units we have in this case, the concentration is mole per liter, which is the same as molar concentration, and then the time was in minutes. Now the value of K, you know that the units can be expressed in terms of what? So for the first order, the units is just going to be time negative. So in this case, it will be minute negative. Okay, so we found the value of K, which is going to be very useful. So the value of K can be shown in the equation to be 0.2, and then we remain with our A and our R. So if you look at now 2, where they want us to find the value of X, you notice that X is representing the concentration of A. So R is equal to, R was given in that case to be 4 times 10 to the power negative 2, and then we're trying to find X, which is representing A. So divide both sides by 0.2, 0.2. You notice that the value of X essentially becomes 0.2. Now what is concentration? So molar concentration, or mole per liter if you want. So that's the value of X. For the value of Y, it is actually the rate, as you can see. So we're trying to find R. I'll put Y, 0.2, our A, or 0.4 there. So Y is equal to 0.2 times 0.4, 0.08. So that is the rate. So it's molar concentration, minute, right? Molar concentration per minute. Now notice that in this case, we've not used any value of B. Why? Because it is not part of the lateral overall, because it raised to the power 0, so its values has got no effect in any of the calculations we've made so far. Okay, that's very important.